Okay, chapter 8. Let's start right away. Let's use a different color. If I put white on this, you won't be able to see it very well. Alright, let's see. Find the geometric mean. So let's do that first. Find the geometric mean between 9 and 11. Let's just kind of put this over here. So the geometric mean is a proportion. Put the x here and the x here. That's your geometric mean between 9 and 11. So you put 9 here, you put 11 here. Cross multiply. X squared equals, watch this, 9 times 11. It says to write it as an exact answer. If you just put 99 and you put the square root of 99, it kills me, but I'll probably give it to you. But you should do it like this. Okay, if you're going to take the square root, I wrote it 9 times 11 because I'm going to take the square root of this side, square root of this side, and then watch, the square root of 9 is 3, square root of 11, you can't do anything else with that, so that should be your answer right there, is 3 square root of 11. That should be the simplest way to write that answer. Does that make sense? Okay. Let's get rid of that. And let's use that geometric mean to solve some of these things. So this is a perfect situation to use the geometric mean. If you have a right triangle, you have an altitude drawn from the hypotenuse, from the right angle to the hypotenuse, that's when we use that geometric mean. So we want to find PS. We'll just call it X right there. X is actually, this thing right here is the geometric mean. Remember, there's 3 geometric means in this situation. One is this altitude, and the other one is this leg, and the third one would be this leg over here. Okay, they're all geometric means. But this is the only one that they ask for in this problem, so we're trying to find PS. Well, you just have to know what it's the geometric mean between. So I got a little space here. Let's just use this space to do some writing. So this time, X is the geometric mean. So X goes here and here. Between what and what? That's what you have to know on these triangles. Well, this altitude is a geometric mean between the 2 segments of this hypotenuse. Okay, so whatever those 2 numbers are. Was that 5 and 8? I know it's a little small. That's 5 and 8. So you just put 5 here, 8 here, and then you can actually go through and find it. Let's do it real quick. X squared is equal to, yeah, you could say 40, or watch, I'm going to go 8 times 5. Take the square root of both sides, so if I take the square root of this, let's take 8 and break that down. It's 4 times 2, isn't it? Times 5. So if I'm going to take the square root of that, no, square root of 4 is 2, and then you can't take the square root of 2, you can't take the square root of 5, so it's the square root of 10. So that would be the simplest exact answer if you're going to do that. All right. Get used to doing this because in Algebra 2 it seems like you have big sections, probably a whole chapter where you have to simplify radicals and all that kind of stuff. So hopefully you had a good head start in here learning how to do that if you didn't learn that in Algebra 1 when you get to Algebra 2. I hope. Alright, let's do this one. This is a little different. No, actually not. It's not different at all. This is one I was thinking of. Yes?
Would it be geometric mean 11 and then 3?
Right. So X is geometric mean. Remember we said either one of these legs of the right triangle could be a geometric mean as well, but it's between 2 different numbers. So X is the geometric mean. This is one of the legs of this right triangle. It's also a geometric mean, but between what? Not between 3 and 8, because that would be this altitude, right? If I compared 3 and 8. But it's between the whole thing, which is 11, and the segment that's adjacent or next to that leg, which is 3. All right, it's pretty easy, isn't it? Watch. They don't tell you, but what if you wanted to solve for y? What would the geometric mean be there? Between 11 and 8. What if that was z, this thing right here, between 3 and 8? Right? If you can memorize those, you can do these with no problem. All right, let's do this. Cross multiply, so x squared equals, and watch, I'm not even going to break down 11 and 3 because I can't take the square root of either one of those, so it's just 33, so x is the square root of 33. And so that's what that x right there would be. Looks a lot easier now, doesn't it, than when you first did those? Seems like I had problems with this.
If it comes out as like an even number when you square root it, just put that in.
Yeah, absolutely. That would be an exact. I didn't say simplified here, but they should be simplified exact answers. All right, let's do this. It's a little different because look, y itself is not really a geometric mean, is it? What's the geometric mean that's shown on this? 6 is actually a geometric mean, isn't it? So 6 is actually the geometric mean. It's not a variable this time. So for some reason, this really stumps people. Well, you got to put the 6 here and here first, right? Because that's where the geometric mean goes. Now, this is the geometric mean between the whole thing. What's the whole thing? It's y plus 4, right? So y plus 4. And the segment that's adjacent to the 6, which would be what? 4. Everybody see that? All right, and now cross multiply, and let's see what we get. Now, if I multiply these two together, I've got to put this in parentheses, distribute this through, so that would be what? 4y plus 16 equals 36, right? 4y equals, subtract a 16, what's that? 20. That's supposed to be a 4. Looks kind of weird. Okay, divide by 4, so y is 5. And that would be your answer, just like that. We good with that? Good. I take your silence to mean you completely understand that. I don't know if that's a good thing or not, but all right. Let's look at this. Find the length of a hypotenuse of a right triangle whose legs measure 6 and 5. That can't be any more easy, could it, as far as Pythagorean Theorem? You know it's a right triangle. You know you're finding the hypotenuse, so we'll call C the hypotenuse. And so basically it's just 6. What did I put a 5 there for? I don't know why. 6 squared plus what? 5 squared. Throw that in the calculator. That's 36. That's 25. Take the square root of that, and you get the square root of 61. All right, and you can keep it like that. On this one, this is actually it does say 1 through 10, doesn't it? Yeah, 1 through 10, all exact answers. So on number 5, technically they don't want you putting that into a calculator, do they? Because it says find a what? An exact answer. This is an exact answer. If I stuck it into a calculator, I would get an approximate answer. All right, so that's really the way I want you to write it. Now again, just because I'm too easy on you, I probably, if you put the decimal answer for the square root of 61, I probably would give it to you, even though I shouldn't. It's just because of the goodness of my heart. Isn't that nice of me? All right, let's do this. Number 6. All right, I'm getting tired of that blue. Let's go to a nice green right there. How's that? All right, look at this thing right here. What do we got? We got a triangle. It's an isosceles triangle, and this is drawn perpendicular. So if it's drawn perpendicular, what does it do to that base right there, that side? Bisects that side as well, doesn't it? So that little thing is a 5. So what are we going to use for this? Yeah, we can use Pythagorean Theorem for this as well, couldn't we? Yeah, that's what we would use. So use Pythagorean Theorem, but we're not going to use the 10, we're going to use the 5. So it's going to be, let's do this up here again, so it's like a little space. So it's going to be x squared plus what? 5 squared. For some reason, I see a lot of people doing this. Whenever they see the variable, they always put the variable by itself. But what's the one that always goes by itself and is not being added? It's always the what? It's always the hypotenuse. That's right. You always got to put the hypotenuse by itself. Right? It's not always just the variable that goes by itself. Does that make sense? That's a common mistake people make. So it's x squared plus 5 squared equals 8 squared. And so that would be, so x squared would be what? 64 minus 25, which is what? 39. All right? And what's that? That's 13 times 3, which you can't take the square root of that, can you? So it's just the square root of 39, and that's it. You leave your answer just like that. Don't even bother putting it into a calculator. It just takes precious seconds away from you, doesn't it, when you're taking the test? So it's good to just keep it just like that. All right. If I'm going a little fast, you can always go back on YouTube and watch them and repeat it. All right, let's look at this. Now, it does say, watch, it says write it as an exact answer. It's a 45 what? 45, 90 triangle. You need to know the relationships between these. Don't use a trig function, throw it into a calculator, and get some decimal answer, because it says write it as an exact answer. So, look, what do I know? I know one of the legs. What's the relationship? Well, the two legs are the same, but that's not what we're looking for. We're looking for this. What is it, Chandler?
Well, you would divide the square root of 2.
Would you?
Nine.
Now you'd multiply, because the leg is the shorter side, right?
I meant like to find the hypotenuse. Like if you had the hypotenuse, you divide those.
If you yeah, but we don't have the hypotenuse, so let's stick with this problem. So we know the leg. So what do we do to get to the hypotenuse? We multiply, right? So if you know the leg, you multiply to get the hypotenuse. Now let's do what you were saying. What if you actually knew the leg? What would you do, or the hypotenuse? What would you do to find the leg? Then you would divide. Okay, but in this case, it's just what? 9 square root of 2. It just takes literally seconds to do, doesn't it? All right. As long as it takes me to write down 9 squared root of 2, that's about as long as it should. Maybe I'll give you like 10 seconds to think about it, okay? But then after that, it probably takes 2 or 3 seconds to write down your answer. So that technically is like a 15 to 20 second problem. Wouldn't you agree with that? All right, then you can spend time on some of the ones that are a little more difficult. All right, look at this one. Now, this one is not a 45, but what? It's 30. Now, how do we know that's 30 right there? Because it's an isosceles triangle, and it's perpendicular, okay? So if this is perpendicular to the other side of an isosceles triangle, it bisects this angle right here. So if this is 60, this whole thing, so that's 30. Would you agree? Actually, you don't even have to know that part, because this is a right angle, this is 60, this is 30. Yeah, I should have thought about that. So what's the relationship, 30, 60, 90?
It's half the short side. So
This is, well, okay, you could, yeah, let's do that. Yep. So you know the hypotenuse, so the short side would be this one right here, because it's opposite the 30. That would be half of it, that would be 6. And now I know the short side, right, and it's just 6 square root of 3. So x is equal to 6 times the square root of 3. I barely had to do any math at all, didn't I? The only math I really did was 12 divided by 2. It is easy, once you look at them and you remember them. I try to convince students that knowing 45, and 30, 60, 90, knowing those relationships makes things way, way easier. But then people say, yeah, but you got to memorize all that stuff, and I don't want to have to memorize all that stuff. But look, it only takes just a short amount of time to memorize it. Once you have it memorized and down, then bang, it makes it so much faster to do these problems. It really does. Okay? So, if I convinced you, great. If I didn't, I'm sorry. I've tried. Find the missing side of a right triangle whose leg measures 48 and hypotenuse is 50. This is another right triangle, isn't it? Okay, yeah, Pythagorean Theorem. If you want to, oops, I'll tell you what, let's do a straight line. If it makes it a little easier for you, you know, and you want to draw the triangle, feel free to draw the triangle. It shouldn't take you too long to do that, all right? Especially when they tell you that. It says find the missing side of a right triangle whose leg is 48 and hypotenuse is 50. So that's 50. And this is 48. I don't know, this is one of another special things. I don't know if you have this one memorized or not, but it is. Watch this. If I, what goes into both of these? 2 goes into that, right? 25 times, and 2 goes into this what? 24 times. Do you recognize, hold up, just give me a second on this. Do you recognize there's a 7, 24, 25 right triangle? Did you remember that at all? You remember 3, 4, 5, don't you? There's 5, 12, 13, but there's also a 7, 24, 25. So if you remember that, then what is the length of this missing side? It's 14, right? All right? So that's kind of nice to know. All right, so there we go. I'll tell you what, let's do this real quick. Perimeter of a square if the length of a diagonal is 16. Look, here's a square. If the diagonal is 16, what's one of the sides? Well, it's 45, right? So what's one of the lengths of the sides then? It's 16 what? Divided by the square root of 2. What do you do to that 16 divided by square root of 2? Well, you're finding the perimeter, so you just multiply it by what? By 4. Okay, then simplify it, and then you're good to go. Okay? So we did half of it. I'll do the other half in the other class.